Nice. Nice to finally meet you.
Nice to meet you too. Oh, and Carlos is here.
Yeah, Carlos, I guess. Yeah, there he is.
Hello.
Hello. I'll be in the workshop in like 2-3 minutes. They wouldn't let me in because it's Sunday.
If I remember correctly, you had a launch yesterday.
Yes,
Yep.
yes. We launched yesterday. It went great. We'll talk about that in the interview. But parachute deployment went great. The actual rocket stability went great. It only went 450 meters away from launch site, which was expected with the crosswind that we had. Everything went nominal. This is our faculty, and below the faculty, the university gave us an old water treatment lab, and they gave it to us. So now it's our workshop. I'm going to show it to you here in a second. Okay, I'm in the workshop now. It's a mess right now because of all the yesterday's launch. Here's the frame. We had a zipper. It's one of the problems we had, avionics, and the recovery did damage the fuselage.
Do you know what happened to the fuselage?
Yes, it's expected because the deployment time was a bit too late, but still within the calculated margin. The problem with a later than expected deployment time, if your rocket is stable enough, it will pitch downwards. So basically the ejection went off when the rocket was pointing towards the ground. And when the parachute deploys and pulls upwards, you can imagine that the cord...
It sort of ripped it.
Yes, it ripped like a 5 centimeter. So here, this cord was expected to pull on the same axis as the tube, but because it deployed pointing down, the cord ripped through the whole, not the whole, just like 5 centimeters.
Exactly.
It's one of the most common recovery damages you can get. Basically, you just need to remake that top part of the fuselage, and it's perfect. There was never a possibility of the cord actually breaking and not being able to recover. It's not ideal, but you just need to remake the fuselage. We are more than happy with our first launch.
Should we start the interview?
Yeah.
Okay.
Hello, everyone. I'm Ettore. I am a rocketeer and a student of a school previously founded by Elon Musk. And today I interviewed the UPV Faraday Rocketry team from the Valencia University that will compete for the 3Km solid rocket competition at EuRoC. Could you please introduce yourself?
My name is Carlos Albiñana Burdiel. I am the Chief Recovery Engineer at Faraday Rocketry. I was one of the original founding members, and I'll let my other teammates introduce themselves now.
Hi, I'm Julio, and I work in the avionics department since the beginning of the project.
Yeah, and I'm Ismael Bouzaza Sánchez, and I'm also an engineer together with Carlos in the recovery department. And I also was here since the start of the project.
What do you do in your team?
Our team began last year, and we were all hell-bent on trying just to make a rocket. We had no clear understanding of how things would go. We had no idea. We basically didn't know other teams in Europe existed. We to be honest, we had no idea Spaceport America existed. We had no idea how the record was set. We just knew that we wanted to make rockets. And then once we started to understand how the whole high-power rocketry scene went, that's when we started to actually have some plans like, okay, we want to reach the Kármán line, or in a future stage, in a mid-stage, we want to compete at EuRoC. So at the moment, our team is only based for rocketry. We have plans for the future to have perhaps a team more focused as well, like a second team more focused on payload. But that's a story for another time, because we are new. We have many things we want to do, but we can't do it all at the same time.
How did you start your rocketry team?
Our rocketry team started because there were two brothers from mechanical engineering that they just decided that they wanted to do a rocketry team, because at our university, there's many other teams that compete in other disciplines. Like, for example, you have formula cars, you have drones, you have aircraft modeling, but we had nothing to do like space related. So these two brothers just started talking with other like last year degree students or even master students. Hey, would you like to make a team? We're trying to gather people so we can sign a paper to create a team, formally create a team. So it all started by sending us WhatsApp texts, trying to gather as many people as possible. Once we were enough, we could sign to actually make a deal with the university to formally. So pretty much it all started by talking, gathering people, and then, as teams go, some people are more inclined to work since the beginning, others want to go a step further. So we wanted to see how it all went.
How is it to study in Spain, and can you study in English?
We can study in English, but I think all of us here, we have studied in Spanish.
There are two separate groups. One studies in Spanish and the other one in English. I go to the English one and my colleagues to the Spanish one. It's basically the same, just the language changes, but it's nice that this option is offered because aerospace engineering is also a very international degree, so you can already get used to the language.
There's an English option for both aerospace and for industrial engineering, I believe. I think perhaps there's another degree that you can study in both languages. So people, when they just enter university, they can choose. But of course, if they get a higher grade, they will get to choose faster than the people who get a lower grade. And once that's decided, there's, as my colleague Ismael said, it's pretty much the same thing. You do the same exact syllabus, just in another language. Both my colleague Julio and I go to the Spanish team, and Ismael goes to the English team. Well, there's also a third language option, which is because Valencia is in the. There's also Catalan or Valencian language, so there's a possibility to do some lab practices or even some to attend class in Valencia. And I actually go to the Valencian team. But
what are the job opportunities that you are in touch with in your university?
All universities have they have organized meetings with other companies to facilitate internships. Solely space related, I don't think the university has any direct connections. Of course, we do have the average connections that any aerospace degree has, like Airbus. In Spain, we have CASA, which is a big company that deals with both civilian aircraft and military aircrafts. We have GMV or GMV, which are not aerospace, but they do more software-related stuff, and they do work with PLD Space, which is the current space leader in Spain, the biggest startup for space rocketry. And we do actually know PLD Space, but that's not thanks to the university directly. It had to do that the founder of PLD Space actually was a student of Aerospace in our same university. So the founder knew one of our teachers, and that way we could get to know him. But that, as I said, it's not a organized university-related thing. We just happen to know this guy thanks to other teachers. As for the European Space Agency, they do sometimes come and do some meetings. But again, if you want to do internships or work with this organization or companies or agencies for that matter, you have to be a bit on your own. The university will, of course, help you, but there's no direct link between the European Space Agency and our university. Aerospace in our university, sadly, I think it's way more focused on the traditional aircraft systems rather than rocketry and space related.
How did you prepare for your university? Like, what high school did you attend to?
I didn't prepare anything. Yes, it was by chance. I mean, I didn't really plan to attend to aerospace engineering, so it was by chance.
I actually knew from a very young age that I wanted to do aerospace engineering, so I knew I had to work hard in the what we call here the selectividad, which is the exam that gets you to university, and according to that grade you can choose your degree. And I pretty much worked hard in order to get to the limit grade to get in the university. So yeah, I mean, to get to the university in preparation you have to work, but that depends a little bit on what degree you want to get in. Aerospace engineering here in Valencia is very demanded, so the grade is really high. But yeah, luckily I got in.
I really wanted to do aerospace, but I didn't know from a young age. I only knew when I was 17 years old, before I wanted to do medicine. Then I was like, okay, I kind of like physics. Maybe I can do biomedicine. And then I started to study biology, and I was like, okay, there's too many complicated words. I think I'm going to stick with pure physics. And because I always liked space, I actually worked hard to try and get enough grade to actually select aerospace in my degree. As regarding if we actually were part of any space association before actually getting to university, I can't speak for the rest of my team. I can only speak with my experience. Rocketry in Europe is not is not as expanded or as popular as in the United States. So as I said, last year we founded the Rocketry Team, and we had no idea the whole high power rocketry scene even existed. In university, myself, for example, I did projects dealing with astrophysics. For example, a friend and I did a cosmic radiation detector, which is basically a cloud chamber, but which is easy to build. Many people have done it, but we tried to make it a bit more interesting. We did with Helmholtz wires, we tried to make a magnetic field to actually curve the cosmic rays and try to estimate their energy with the radius of curvature. So that is my experience, but I know many other teammates in Faraday have done similar things while being in school or almost university, and that shows the level of ambition that we have towards space.
What are the goals and strengths of your team?
I believe that one of the biggest strengths is the high amount that such an amount of people want to work with us since the very beginning. I've been talking to other teams. I don't really know all the teams, but I've talked to some. We've come to realize that for being a new team, we are many members. We're already over 40 members, and more than those 40 members, we have 50 people in the waiting list. So that's our strength. We have many people that actually want to cooperate and work and put in the effort to actually make something big. So that's also, we are very, very active in social media, and we try to engage with any organization or any event that the university or other private industry is trying to build to pretty much get us, put our name out there and show the world that we're here for something big. It's hard work to try and show up to every event that there is, but slowly but surely we're going to get there. If there is any plan to actually step outside the university realm and actually go private, that's a story for another time. We don't want to rush things, as I said, we were founded last year. We don't want to start talking big numbers as in, well, we can do like a spin-off and actually work with Spanish space industry sector. Let's see how things go at EuRoC. Let's see how next year our plans go, because we have big plans, but talking about spin-off and other activities, that's a whole different ballgame.
How can someone join your team?
Do interviews to get to know the candidates, and we chose whoever is more prepared for the job in the short term. We have very specific needs, like for example, now we have hired working on Kalman filters, and we are very interested in that in the avionics department. So we have like let him join the team.
And also in recovery department, we also have a new member which we were looking for, which was someone who could work with CFD, computational fluid dynamics. And yeah, we basically send mass emails to the faculty and to the people in the waiting list and put the criteria. And if people meet the criteria, we do the interviews and select the people.
Right now, that's what we do, because we can't accept more people. We're already 40 people. We don't have the capacity to mass accept everyone, which is sad, because we would like to get the bigger the team, the better. But we have our technical limitations. We can't just really accept everyone. So right now, we're sending mass emails to see how many people fit the criteria and are interested. We'll see from all the people that actually replied to the emails, we'll do, like Julio said, we'll do some interviews, see which profile fits our goals the best, and we'll let him join the team. At the very beginning, because we just let everyone in. We were looking more than for specific profiles with technical knowledge. We were looking for ambition and goals. Like, will you want to work here? Are you able to put in the effort? Because we can't expect anyone to actually know how to build a rocket when we ourselves had no idea how to build a rocket in the first place. A good example of a candidate will be someone who is like, okay, I don't know computational fluid dynamics because I'm only in first year or second year, but I'm willing to put in the work and learn in a few months to be able to be useful to the team with new technologies that none of the other colleagues are able to do. That's pretty much what we look for. We look with people with ambition.
Can someone join an online design review?
We haven't considered at the moment the online review for everyone, but of course, yes, we are actually looking for people that do have rocketry experience to be able to review or design our review our design, because as you know, we're new, we're gonna obviously make mistakes. We've had help from people from the Spaceport America. We've asked European teams for help. They've all been very helpful, which we're very thankful about that. If you want to join and actually help us review our rocketry, we'll be more than glad to consider your offer. However, we can't just be showcasing our design because that's the core element of competition. We are not a very secretive group. We'll talk about that later. But of course, we can't just be freely showcasing our work. We want to keep that more of a bit of a secret for the competition aspect.
How do you support and manage your team?
At the moment, as I said, we're over 40 members and we have 7 departments. So we have avionics, we have propulsion, we have structures and engineering and aerodynamics. We have manufacturing, we have recovery, we have research development.
Development and investigation.
And investigation, yes. And then marketing department. We are about between 5 and 7 members per department. Each department has a chief or head of department. All the chiefs, engineers, they form the board of directors. So the board of directors will do weekly meetings just to see how everything's going. Then we have bi-weekly or every 2 weeks, we have meetings with the whole team. Everyone joins in. And every department goes up to the stage and then talks about how what things they've been doing for the past 2 weeks, just so everybody gets an idea or gets a scope of what's been going on. As you know, if you are only dealing with recovery aspect, perhaps you're forgetting about things that manufacturing or things that propulsion problems that they have. And it's been very interesting to see that sometimes people that don't belong to a specific department, to your specific department, they actually come up with a solution because they're able to see the problem with a wider scope, as they're not so focused. We had people like Jordi from our manufacturing team give us great solutions for recovery, for example. And he's not a recovery engineer. He has no idea how, he has basic understanding of how parachute works. But I remember we had a problem with the ejection system because originally it was going to be spring-based, but we wanted to innovate and not do neither CO2 nor technical deployment. We wanted to try to do spring-based, and he actually helped us design the spring-loaded system. Part-time or full-time positions like other more established teams have. I believe Delft, their Delft project, they have like engineers that are actually working full-time. In our case, it's only students on their part-time. Not with part-time, I mean that whenever they finish class, they can come by with the workshop and start working. How's
the experimental rocketry and space community in your country?
Basically, we think that the space industry in Europe, like Rocketeer branch, is a little bit underdeveloped in Europe. but there are definitely some big steps being made. Like, for example, EuRoC began, I think, 2020 as a response to Spaceport America Cup. And also I heard there's some initiatives to make launches together with team members throughout Europe. So there's definitely the will from rocketry teams to make a real industry from rocketeering. But right now it's far from what there is in America.
Space community here in Spain, there are, if I'm not mistaken, 4 rocketry teams and one big CubeSat or project that is solely based on the payload system. So we have STAR, UC3M from Madrid. We have Cosmic Research from Barcelona. We have Bisky team from the Basque country. And then in Vigo, there's in Galicia, there's a team that deals with the CubeSat competition. So we were very, as I said, we had no idea HPR rocketry even existed. So we were very happy to see that there were so many teams here in Spain. We did not expect that, but we are happy about that. They've been very, very helpful with us. When we began, we asked them many questions and they were all very supportive. Also, I have a fun story with the Madrid team. When we bought some systems from Aerospace, from Aerospace Technology, the guy got confused and he sent some of our products to the Madrid team. And the Madrid team just replied that they sent it back to us with a note and merchandise. So that was a fun story. So thank you if the Madrid team is watching. Thank you about that.
How do you test your rockets and where do you launch them?
Our first launch that we did yesterday, it was done in Albacete in a small airfield. Basically, the criteria that we were looking for is some place that is relatively close to our city, Valencia, but has the least amount of things or buildings or infrastructure around the set place. So Albacete, which is a province close to us that is it has lots of fields with pretty much nothing there. That was an ideal candidate. We started ringing every airdrome we could find with other provinces close to Albacete. And the owner of the airfield was very, very supportive of our idea, and he let us use his airdrome. Of course, we need to ask for more things. We need to ask the Spanish aviation agency for a NOTAM, which is a document that certifies that you have this window to launch. We needed to call, in our case, San Javier, which is the base that controls the airspace of that area. We needed to have a document that certifies that if anything goes wrong, we are able to cover the costs. We had to do lots of paperwork in order to launch our rocket. That rocket that we tested, we were able to test it there in an airdrome because it was only 1 kilometer apogee. When we start dealing in the near future with higher apogee rockets, we won't be able to just launch there. We'll probably have to ring Hermosillo, which is the actual big spaceport in Spain. We're trying to talk with the army to see if they will let us use their infrastructure, but that's a whole other story. Actually testing rockets, that's where we do the actual whole test with everything. But of course, we test every subsystem separately. So we will test propulsion engine or system here in the university. We will test the parachute recovery system with a drop test just from a very tall building here in our university. We're trying to get local airfields to let us use their airplanes to just drop, or helicopters, to just let us drop a dummy rocket with a working recovery system. It's very difficult because Valencia has a very controlled airspace, and it's proven to be harder than we thought. For how many kilometers of free area? Well, it all depends on the crosswind and the apogee. I can't talk for all cases, but I can give the example of yesterday. Yesterday, we needed a clearance of 800 meters with 12 knot wind. The rocket actually ended up 450 meters away from launch site, which was expected. So that's a very small clearance radius, 800 meters, in the direction of the prevalent wind. But of course, it grows very, very fast with Apogee. Other more established teams will tell you about that.
What do you think of the Open Launch Initiative?
Well, we were very interested in since the beginning with the Open Launch Initiative that Josiah Coy came up with from Astra Bremen, because being new, we had no idea that paperwork was going to be this hard and difficult and expensive, especially. I don't know if I'm legally able to say numbers, but they are very, very high. So of course, when we heard about this initiative to join many other teams, and instead of just one team actually having to pay for the whole, half-day window to launch, many other teams can join and we can launch many rockets, and that would be great. From many points of views, both economically, it's better for everyone. We get to network with our teams. We get to actually see other teams in action, so we can get more experience. I think it's a great idea. I mean, there's the obvious problem of having teams interested, but from opposite sides of Europe. Like, it would be very difficult to do for us, for example, to, I don't know, just to give an example, to work with Propulse from NT and U, because they're so far away from us. But I don't know, Madrid or Italy or French teams for Spain, that would be great. Or even Portugal, of course, which are our neighbors. So yeah, we were very interested. We'll see how the meeting goes.
For anyone watching, the Open Launch Initiative is the idea to go to a spaceport and share the price, because it, as you said, Carlos, it costs a lot of money. And so if many teams share the price, then for each team it will cost less.
Yes, exactly. We'll talk with spaceports and see the availability of actually having more than one rocket at the same time. But we'll see how it goes. We'll make an update.
How do you make your public relations?
In our team, we have a really good marketing department, which is dealing with all of the stuff like social media, posting, and public relations. And the content that they do is, I think it's pretty nice, with all the promotions of the team, also some funny gags on Reels on Instagram.
They are also very focused on keeping in touch with aerospace companies here in Spain. Sponsor us. So yeah, we have a very strong marketing team.
Yes, as for YouTube videos, which are pretty much the only last thing that we're missing, we are on the process of actually making a YouTube channel, but that will require more, not effort, but I believe somebody new, because we already have someone dealing with Instagram, we have somebody dealing with LinkedIn, and they are all very busy trying to keep in touch, as Julio said, with other companies. We really want to get a YouTube channel going by this summer. I will upload some videos, I can talk about that later, and I would really like to upload those parachute recovery videos with the official Faraday YouTube account. We'll see how that goes. I believe that by summer we'll already have a YouTube channel. At the moment we don't have, but it's planned. As for how we manage our communications, well, we have a weekly board of director meetings. That way we can talk, we can share ideas. But of course, the marketing department is the one that actually knows how to do this stuff. We can just give our opinion, and they will give, for example, hey, we have this video idea. We need said department to actually start building something so we can do a montage or whatever. We really like to, instead of just sending an email, we try to prioritize local companies, just because we can actually show up physically there and talk person to person, which we believe it's more, it yields better results when you can speak with somebody physically instead of through a meeting or just an email. They've been very receptive when we actually meet them. We will call, hey, we do rockets in our university. We've seen some of your products. We're very interested in what you offer. Would you like any sort of agreement? Can we go tomorrow and talk to you in person? That's how we get in touch with possible sponsorships.
What are your future plans for EuRoC?
This EuRoC edition, we run to, as you said in the very beginning, we want to compete in our COTS 3-kilometer apogee rocket. Our main goal at EuRoC is to perform to the best of our abilities, but we are very excited to actually know the rest of the teams because they have more experience than us. They can give us many great tips, and we will sure gain weeks or months of experience just in those few days, just by talking to other teams which actually have the experience. As for next editions, we'll see how it goes. We really have no idea how we're going to deal with future EuRoC editions. Maybe we try to develop a bigger rocket for EuRoC, or we develop the same 3-kilometer one whilst developing a bigger rocket just to try and compete at EuRoC in the same category. We'll see. What is obvious is that if we compete in newer editions of EuRoC in later years, we will try and get a SRAD motor going on. We tried to get it in time for EuRoC, and it works, but we are not confident enough at the moment to actually say that we will compete with an SRAD. So that's why we went with the commercial rocket. We'll see in future editions how it goes. We're talking to our university to see how they can see if we can get to an agreement as to how many people can go, because it's, of course, there's the budget. We can't actually ask for too much money to send only 30 people there, because at EuRoC you can send 30 people. We'll see how it goes. Maybe there's luck and we can send all 30. As for advisors, for sure, 2 of our advisors will show up. Our propulsion advisor and the actual team tutor will show up. You'll get to meet them in EuRoC if you come see. As for who are the top competitors, I don't want to say things and then I'm gonna regret. But I believe that I've met a member of Phoenix Rocketry today, and they seemed very, very focused. I'm not going to speak about other teams because I haven't met them. I've only talked to them through social media, so I don't want to say anything. I've only met in person somebody from Phoenix because he's doing Erasmus here. And they seemed small but promising team. We'll see. We'll see how.
Do you want to join other rocketry competitions?
If the Open Launch Initiative actually goes as planned, or we actually yield or get a result that we can actually join with other teams, we will for sure. Spaceport America right now is not on the table because it's way too expensive for us. Can take 20K or 25K euros to send the rocket with the whole team to Spaceport America. We don't have that kind of budget. That's 5 times our current budget. We can't deal with Spaceport America at the moment. Perhaps in the future, yes, but I don't believe that this year or the next we'll have enough money to have enough to send a whole team, to send a rocket to Spaceport America. That's why we are very focused or very intrigued by expanding the European space scene to see if we can make the European competition just as big or bigger than it currently is, to attract more people and because Spaceport America, there's many more teams competing than at EuRoC. We really wish that EuRoC was just as big as Spaceport America. In any specific country, well, it's not about the country itself, it's just about how available we have it to actually send our rocket there. We're very grateful that Spain actually has one of the spaceports, so that really lowers our the budget, but it has to be in Europe. We don't really care what country, but we just can't send across the Atlantic a whole rocket. It's way too expensive. Also the delays, because you need to send it with doing so much paperwork, doing so many things in advance.
How do you finance your team?
All the teams in our university, they are all part of what it is called Generación Espontánea, which translates to spontaneous generation. It's basically a branch of the university that deals with and helps, promotes, encourages the creation of teams. which are very that they can deal with many things that you have, from comic or theater teams to more engineering based teams like Faraday, for example. You have Formula, you have Horus, which deal with drones. You have so many teams. We send in the how much our budget needs to be, more or less. They will receive our proposition. They will either accept or decline. And if they decline, they will say, okay, we can't give you this much money, but we can give you, say, half of it. Budget for that season. That's how we get support from the actual university. Then we get support, as you know, from sponsors. Most sponsorships at the moment are not with actual money. Just that, okay, we believe in your cause. We want to make you grow, but we can't actually give you money at the moment. We want to test the waters a bit, if you know. So because we want to still show our appreciation and our support, instead of giving you money, what we're going to give you is, a discount, or we're actually going to give you this stuff for free, or we're going to give you a 600 budget to spend at our company. It all depends, company from company. They all give us a different agreement. As for if it is easy to find what we need in our area, because our current rockets haven't been very, very complicated. Other teams that are dealing with liquid cryogenic propulsion, and it hasn't been very terribly difficult to find what we needed. Most of the stuff that we needed to make the rocket that we launched yesterday, we could find in not very local, but in the Valencian area. We could find companies to work with. We had no problems during COVID because we were formed when COVID was already on a decline. Valencia, or the whole Spain for that matter, doesn't have such a strong industry as other countries in Europe, because Spain is a very, has a very big service sector. It's very focused on summer vacations. And when you have to deal with actually like metalworking, we do have stuff like every country, but like I believe Poland or Germany or Austria, they have much bigger, industrial areas than we do. But we can manage with what we have. If we have famous sponsors, I mean, they give us their licenses to their NX-CAD program. They give us Star CCM for computational fluid dynamics. But all the other sponsors that we have, they deal directly with rocketry scene. I mean, not directly, but they have a direct involvement. RS company, they give us electronic stuff for avionics. We have Astos for the simulations.
Integrated circuits, which is very interesting to RS components, indeed, I think. Yes, we have plenty range of sponsors with who are pleased to help us.
Yes, I have a fun story about a sponsor that is gonna give us the drogue chute for our EuRoC rocket. I just started ringing every parachute manufacturer I could find in Spain, and I found this textile manufacturer, but it's very military based. Like, it deals with military stuff. It's not just civilian parachuting. It's more military or personnel for artillery or ordnance. But it will work great. They've been very helpful with giving me tips for the design of our parachute system, and they will actually give us their one of their retarding personnel parachutes for our drogue chute at EuRoC. I say that it was funny because I will call them and it was like, yes, I have this M30 artillery parachute ready for you, and I'm like, look, I don't want to deal with war. I have no idea what an M30 bomb parachute is. If it works, I'll use it. I have no interest in if it's used for bombs, artillery, ordnance, or personnel. I just want the drag coefficient to be what I want and the actual diameter to be what I want. I don't really care about if it's used in war or whatever. That was fun.
How much do you build your rockets?
We have the commercial motor and the parachute. We buy either from Fruity Shoots or we buy from other companies that deal with actual rocketry. Or as I said, our sponsor will give us their drogue chute. Apart from that, everything is made by us. But by us, I mean that, for example, we don't have a CNC machine. We don't have a 3D printer. We'll ask both universities and private companies to try to get an agreement. We will design the parts that we want to see and that we want to machine. We will design the parts that, for example, the PCB or the avionics bay. We will design that, and then we will ask companies to implement our design and to give it to us. But we don't have the actual machines to do it. Right now in the workshop, I can show you afterwards, we only do the fiberglass tubes. We buy all the fiberglass sheets, we buy the resin, and we manufacture the fuselage and everything here in the workshop. Soon we will have, we're dealing now with aluminum and steel parts, both for nozzles and other parts of the rocket. We do 3D printing at our university. They have been very helpful and supportive. There's a big 3D printing scene in our university, and the professors, researchers, and people that deal with those kinds of stuff, they've been very helpful with last minute checks. Sometimes will have to be, oh, we really need this piece by tomorrow. Could you please print it? And they always answer. So we're very thankful for that. If it wasn't by them, probably our rocket wouldn't be here, right? As for what type of engines we're doing right now, we're doing the most basic solid rocket. We're doing sorbitol and potassium nitrate rocket, the sugar rocket, basically. There were plans to make chloride and aluminum powder solid rocket, but I think we're going to scrap that idea and we're jumping directly to liquid propulsion. It's going to take, probably in the next year we won't have it. We really want to have by next year some testing, like workbench or something that we can actually show. But liquid propulsion is a whole nother story. It will take minimum 2 years to actually develop a liquid rocket that actually fits in an airframe. We can't just jump to liquid propulsion and go for the hardest kind of liquid propulsion. So we're gonna jump to non-cryogenic liquid propulsion next. We'll see. I don't want to speak because I don't know if the propulsion team wants me to make this public, so I'm not gonna say which propellant we will use. But that's how things are going right now with our DIY.
I will say ethanol is a good fuel for liquid-fueled rocket engines.
Yes. I might as well just say it. They're probably going to use nitrous oxide and ethanol or kerosene. I don't remember if it's kerosene or ethanol, but it's nitrous oxide. But it's not definitive. They are still working and trying to speak with researchers to see how available or how difficult making all the different parts will be, how much budget we will need, because it's going to be very, very expensive. For example, we have this support from our university to make this liquid motor or liquid engine, but we don't have the facilities to actually test it right now. So the budget will have to increase because we will need to build both the actual rocket and something to actually test it. So it's going to be so expensive that we're still seeing how it's going to go.
How do you make prototypes?
Yeah, well, for example, the rocket that we launched yesterday was a kind of a demonstrator of our avionics and recovery department. So prototypes, what we do is we, as Carlos said, we build them with the materials that are given us from the sponsors. And we have the facilities that are next to Carlos right now to make the fiberglass tubes and the fins with epoxy also. We designed them ourselves, build them with what we have. And I think the results are really promising. We can tell you later on about the results from the launch. And yeah, about the software, I think Julio can tell you more about that.
By now, we do not develop our own software. We just use commercial software as for example, for the integrated circuits, we use Altium, which is our sponsor, and we do not develop our software. We have developed our own interface for the ground telecommunication, ground to air telecommunications, but that's all.
And that's for the CAD systems for the actual rocket. We use Siemens NX. That's and we also use OpenRocket, but we're switching now to our sponsor. And then to test the SRAD motors that we will use, we're using Star CCM to do the transient behavior of the rocket, for atmospheric aerodynamics as well, to design the fins, the airbrake system, and I think that's all for simulation aspect.
Do you plan to use thrust vectoring?
Not in the near future, because that's thrust vectoring in itself, the actual software aspect of it is not that difficult. The most difficult part is the actual build of the thrust vector system. We really want to make a thrust vectoring TVC system, but not next year. It's probably going to be the year after that. Maybe we're going to get something working, because as I said, it's the hardest part is not the software aspect. It's the actual building a working system with TVC. As for attitude control, maybe we'll do some RCS system, or maybe we are surely developing right now an airbrake system. Hopefully we can get it in time for EuRoC rocket. We have 2 of our members are doing their final degree project on the airbrakes. One is designing the control system in MATLAB Simulink, and the other is designing the actual physical airbrake. There's many plans for the future, but we can't just jump in and do everything at the same time. So right now, thrust vectoring, of course, we want to do that, but it's not on the table right now. Right now, we're focusing our efforts in airbrake systems.
What kind of fins do you use and why?
Sadly, I don't have my structures and aerodynamics teammates with me to actually help me answer this question. I can just answer the manufacturing aspect of it. We were using wood, and then we were doing tip to tip with the fiberglass, and then we were doing the fillet to the rocket to give it more aerodynamic shape. I can only tell you I don't remember the actual reason for it, but our prototype used trapezoidal fins. When I send you pictures, you can post it on the video. And I really believe that the EuRoC rocket will also use trapezoidal fins, but that maybe changes when we review how our rocket went in the launch yesterday.
Yes, but by now the aerodynamics head of the department, and they are really focused on simulate many fins to improve the aerodynamics efficiency and the.
How do you transfer the data from the rocket to your computer or some other device?
By now, the communication is very simple. It's on the simplest way of communication, and we try to go to a bit further to a LoRa system, because by now we certainly know that we can't we can meet the range of 3 kilometers with our ground station at the moment. So we are focused on now LoRa antennas for the Euro competition.
We want to get an auto tracking antenna going on.
We have a prototype of tracking antenna, but it's not. You have to make it work. So it's only a demonstrator. We have to really focus on that part. I can't really tell you that much of information that I wanted to, because I'm not of the ground station team. I'm not the avionics in the rocket team. So
what launch rail do you use?
The one of the sponsoring companies that we have, they gave us profiles. They couldn't give us the specific profiles that EuRoC wants to use, because I believe that when you go to EuRoC, they can give you one of the rails. I mean, it works with the same idea. You just have some guides that slide through the rail, and we used a 3-meter aluminum profile with 4 legs that we just secured to the ground with very heavy sandbags. As for because that was only 3-meter long rail, that it could only be one piece, and we could transport it on top of our cars. However, for the EuRoC rocket, it's going to be much longer, and we're going to make it into, instead of a single rail, it's going to be more of a triangular shape, like the ones that you can see in cranes. And it's going to be able to subdivide it into 1-meter pieces to actually build the bigger rail. And it's made from standard aluminum profile. We want to make a crank system so we can change the initial angle of launch. The structures department is working with that.
How do you recover your rockets?
We first tried to reinvent the wheel a bit, just to try and show our abilities. But then we quickly realized that it's better just to stick to the basics for our first rocket. And many teams do CO2 cartridge ejections because they don't damage the actual parachute cloth or the lines, for that matter. However, we didn't have the budget to actually buy the commercial CO2 ejection system. So we first tried to create our own CO2 ejection system, but the schedule was running tight. We wouldn't get in time if we had to design our whole CO2 cartridge system. So we just had to deal with the most basic pyrotechnic ejection, which actually worked great. Of course, CO2 ejection is limited to big rockets, but not the high-end big rockets, because the bigger the recovery system, the more black powder you need. The more black powder you need, the higher the pressure inside. The hot gases can actually infiltrate through the heat shield cloth and actually damage your rocket and destroy the whole recovery system. So in the future, of course, we will definitely use non-pyro ejection. But for EuRoC rocket, I think we will definitely use pyrotechnic ejection, because if you're careful with the material selection and you actually do your burrito wrap with the heat shield cloth as you shouldn't have any problems with a 3-kilometer apogee recovery with pyrotechnic ejection. We use very contrasting colors in our parachutes, so we can actually see our rocket is black in color and then the parachute is white and red. You can actually see that very clearly in the sky. We do have the tender descender system, which is commercial, but then we're going to have redundancy because we're developing our own separation system, which is based on the triple ring system. We thought that we had a very big idea with that triple ring system, that no other team actually tried it before. But then we quickly realized that Washington team tried it before. Other teams already tried triple ring separation. But we're going to try and do our own system. Right now it works. It has really good capabilities with around 200 grams of retention force. We can do the 40-kilogram steady state force, which is great. Yes, we'll do both the tender descender and the triple ring system in series for redundancy reasons, and then just the lines, because it's Kevlar cord for the pyrotechnic ejection. Kevlar is much more stiff than a nylon paracord, so to absorb part of the shock load and opening force, we just Z-fold the lines with some braking bands and elastic bands, and the breaking of such bands absorb part of the shock force and enable the parachute to deploy without suffering as much.
You play Kerbal?
Well, me, I think it's one of the best games ever. Very good game to get in touch with rocketry, I think. And it also tells you a lot of things about the physics of a rocket. For example, I don't know, allow me to say, Etto, that I saw one of your videos from Kerbal Space Program, and I found them really good. And I don't know if you experienced this, but at the beginning, well, at least me, I placed the fins of the rockets in really, like, on the top of the rocket, and every time the rockets were unstable, So with time, I learned that what the center of pressure was, where the center of gravity should be in order for the rocket to be stable. So I think that's one of the main points that these games show you. And yeah, I really enjoyed it. And also lots of orbital mechanics, which will be helpful later on. But yeah.
At the start, I had the problem that I didn't understand how the throttle worked. So I got like the swivel engine. I was, why is this not turning on? I'm pressing space. After watching 5 tutorials, I understood.
Exactly.
What payload do you use?
At the moment, we're using some CubeSats that are going to take some air measurements from the on the way down and on the way up. We want to develop more complicated systems in the future, but with the time we had for EuRoC, our R plus D plus I's department came up with that idea. They're developing the system right now. Right now, it's non-deployable payload. In the future, we really want to make some the payload to be able to deploy. For the demonstrator yesterday, we just used a dummy mass because it wasn't our objective just to test the payload. We just wanted to test recovery and the avionics. And about a controlled parafoil, we're studying that possibility, but we have so many things at the moment that we're going to stick to the EuRoC competition ready rocket, and then we'll see about trying to make the systems more interesting or complicated payload systems.
Do you have any big announcements?
The biggest announcement is that yesterday the rocket worked almost perfectly. By almost, I mean that apart from avionics, everything went great. Julio can tell you about avionics.
Well, I mean, I don't know how much I can tell you because there's a lot of things going on in the avionics system, but we are sure that the parachute was deployed because of an emergency algorithm that we implemented in the last days. I mean, it was like 2 lines of code that literally saved the rocket. It was mad. We had an algorithm based on the mechanics of the rocket, but it didn't work. We must study why it didn't work. So that's our goal right now. But yes, it was mad. The deployment of the parachute, I was having an anxiety attack when I see the rocket on the sky and the parachute was not deploying. We were all watching it and we were like, oh, damn. It's not what I pray, but it was like a miracle.
Like when we saw the rocket reach apogee and start turning downwards, like my heart stopped beating for a second, but then as we saw the little red point of the parachute, the crowd went wild, we went wild. It was all in all, I think space launches such as this are really, really good experiences because it's a lot of emotions crammed together with all the hard work you've put in and all your friends and team colleagues which are there. So yeah, it was a really good.
Yeah, we were very happy to see that our very first rocket and a year worth of manufacturing and studying and working after class late, sometimes not sleeping, actually yielded a good result. We're sad about avionics, but we'll figure it out and we'll do a second launch soon to test. And then we'll do our 3-kilometer one, hopefully within less than 2 months.
What are your personal future plans?
I'm awaiting in a few days' time. I will see. Maybe I will go to study space engineering, Master of Science in Milan. If I am not accepted, I'll probably study computational fluid dynamics, MSc here in Valencia, and focus on the team. That's my personal experience. Some people really wish that Faraday became a spin-off or even startup. We're still in a very early stage to actually be thinking about those sort of things. If actually in a few years' time Faraday became a startup, I would for sure come back here and be part of it. I don't know where I'm gonna end up. The other teammates will tell you other stories.
To say that after working here in Faraday, I got really hyped into the space sector. So I'm really focused into working in that sector. In Europe, like the dream companies would be Airbus or Arianespace, or also SpaceX in America. But I think that for SpaceX, you actually have to be an American citizen, so that would be a little bit complicated. But they are really good because they are the pioneers of technology. Like they have, being the private sector, they research a lot and make the best engines and yeah, all these retropropulsive recovery is really nice. But yeah, you never know where life will guide you.
Yeah. And as for me, I don't even know what I'm having for lunch today, so I don't have any plans for future right now. I just keep going.
Do you have any advice for young Rocketeers?
First thing is just to rockets seem very scary at the beginning because they are. There's many things to study, many hours of work to put in, but there you can go in stages. You don't have to gather 40 people to design a 1 kilometer rocket. That happened because we really wanted to make everything DIY. We really wanted to get from 0 to 1 kilometer in the get-go. But if you are young, just get in touch with local like more experienced rocketry teams or just people who actually deal with rocketry, and you can buy half-done rocketry kits to just test the water, just launch a few even water rockets, which are very simple to make. And once you start getting experience with kits, you can start designing your own rockets. See if you can make first cardboard. After cardboard, maybe you can buy an actual fiberglass tube. Start little by little. You don't have to go big like us. Just try things. Then things will work out. You will gain experience either way.
I'm from the avionics department. I just can say that anything can fail at any moment. Anything. I mean, that little sensor that you thought, yes, this is secure, this is gonna work, 100% of the times that can fail. You have to be very aware of that, but you don't have to be scared of that. You must learn of that. You must learn of your mistakes and of the fails that you commit on the.
And also, if something bad happens, don't frustrate and scrap everything. Just keep learn from your mistakes, as Julio said, and try again, and don't give up. And at the end, you will succeed.
What are your favorite space movies?
I'm gonna go with the cliche, Interstellar. From the beginning to the end, is amazing. Is very respectful with the physics laws. It's realistic in that, if that matters to a film, and I really enjoy it.
Yeah, I like Interstellar, Mars, and everything, but I also would like to point out the film Gravity, which is about a space shuttle that goes wrong when repairing Hubble. And it might not be 100% realistic, but it shows very well how anything can go bad in space, and everything is a chain reaction, and well, how to get safe to Earth. I think the graphics were amazing. The story was also amazing and very thrilling. So yeah, I really enjoyed it.
I'm gonna go with a more philosophical and psychedelic approach. I really like Space Odyssey movie and the book. I read it 5 times and I saw the movie 5 times, and I think it's probably one of the best movies ever made. I really like. Encourage anyone to watch it. As for YouTubers, wow, I have a really big list. But if I had to mention anyone very specifically space related, PBS Space Time is great. Everyday Astronaut is great. Scott Manley, of course, yeah. Those are the basics.
Spanish YouTubers. So, for example, well, it's not that small. For example, Quantum Fracture. That's for physics, not really rocketry. Latin Voltio is also but they are very little, and their content is in Spanish.
Well, of course, I almost forgot about BPS Space. They really inspired us at the very beginning with their systems, especially with how it didn't matter how outrageous it seemed. I'm gonna make a SpaceX model with actual TVC system. That approach to rocketry really inspired us to just try things. Let's not trying to do the safe thing. We have a low budget, but with our low budget, let's see what we can do. Let's just try. That's why we're like, okay, we already finished solid rocket. Let's go straight to liquid propulsion. Let's just skip hybrid motors. That approach that inspired us. So that's a YouTuber we want to shout out.
In which of the space movies would you like to live in? If you had to choose a movie universe, which one would you choose?
Well, obviously Star Wars. Obviously Star Wars. But
I agree.
statistically speaking, I would probably be for Alien. But when I say Star Wars, I would be Star Wars, but either a Jedi Knight or something more interesting than just being a slave to the Imperial system. But yeah, obviously Star Wars.
I'm gonna go with Doctor Who. I would love to travel in a TARDIS, even if I wouldn't meet the Doctor in the universe, but it would be amazing to travel in space and time.
Me personally, please don't kill me, but I have not watched Star Wars, so I cannot really tell. Yeah,
Well,
sorry.
Me
Sorry,
neither.
But from the other movies, I couldn't really decide because they're all good in their own aspects, and also I couldn't really tell.
Yeah, and if I have any question for you, more than a question, is more a word of encouragement. Like, good luck with your own rocketry team. You told me yesterday that you were starting to actually gather people. So good luck with that, and hopefully you can show us big rockets in the near future.
For me, I have a question. How does it feel? How is it to be in that academy of founded by Elon Musk? Which is your experience?
It's definitely better than the local school I've got here in Italy, and the level is definitely more advanced. And you don't study Italian, so if you want to study Italian, you shouldn't go there. There's English, and I don't like Italian, so that's good. It's more towards the sciencey, physicsy part. I don't think there's a geography or history lessons. There are many people. I think there are about 200 kids, and there's a very long list of subjects you can choose from. I've chosen terraforming, which is
Wow.
terraforming. Not much to
Really?
say about that.
Really, Elon Musk.
Then I chose synthesis, which are like some games, but there's lots of strategy and they're interesting. There's lots of teamwork. There are many different games and there are teams, and then every team does not know the rules, and you have to find out the rules of the game, how the game works. And then you have to try out to win against the others. And then I also chose applied science. There's a very good teacher. Every now and then he takes apart old television or a microwave. He hasn't done an oven yet, but I think he will do it in a bit.
Oh, very interesting. I wish I had contact with such subjects when I was 12 years old.
Yeah,
Yeah.
exactly.
We didn't have that range of subjects. We had history, geography, maths, and that's all.
Yeah.
The very basic one.
And I also would have a question for you, Ito. We've all heard your story, and we were all amazed by what you've done at such a young age. And I would like to know, what are your plans for the future? Like, maybe where do you want to work? In which branch? What do you want to, let's say, what's your dream job?
My idea is now I'm starting this club. The university that is in my province. I think that when I end school, I think I'll go and make a cooling company, because I've tested out that when water evaporates, it takes heat. So I had the idea of like making something which cools the air that does not require electricity. And then I think I'll sell that company and I'll use the money to make a rocket company.
Kind of what somebody also did, right?
Yeah, somebody.
Somebody cool.
Thanks for being here. For anyone watching, please comment, like, subscribe.
Thank you.
Thanks for having us.
Good luck with everything.
Yeah.
Thanks.
See you.
See ya.
Bye.
Goodbye.
Goodbye.